all of them or a part of them. Please remember IoT, the word thing I will be defining a little later, but try to understand this. If you see here, there is a hospital here, and an ambulance is approaching or ambulance is going away from the hospital. Okay, so what has happened is basically the hospital has picked up a signal from the home that there is some person is required to be attended here. So before a person makes a call, the ambulance has started moving from the hospital. Okay, that's the kind of applications the IoT on the IoT platforms people are trying to build up. Similarly is the case here. Just look at this, the second part of this. Let me just see if I can get some pointers here. Okay, so let me just take this pointer here. Okay, just see this portion now. If you see this portion, this is a cargo is approaching towards a warehouse. Okay, and there is another cargo which is being taken out of the warehouse. So you can see whether it can really find out whether the space is available with the car within the warehouse and so on and so forth. There are some other use cases which are also depicted here. So basically, if I see, I'll try to put up the presentation in the following outlines. That is how to define the IoT, the characteristics, the physical design. But more often than not, I deviate from the outline, and generally, I do not present the outline this way. So let me just start with the first part of it. What is the term IoT? Okay, and so IoT, if you see, there are two basic words which are used here. One is the internet, and the another word is the things. So basically, Internet of Things, when I say, it comprises things that have unique identifiers and are connected to the internet. So these things may range from anything to anything. Okay, I'll be defining the word things a little later. But basically, you can think of it this way, that you have an infrastructure backbone, a communication backbone, and there are certain devices which may not be the classical computer terminals or your laptops or your mobile devices. Okay, this may be anything, ranging from a washing machine to an oven or to an air conditioner. And what happens is they are connected to the internet. And so there is a control, there is a communication established with these devices and the internet. Now, the requirement is that each one of these devices, which we call things in the in the field of the Internet of Things, they are assigned unique identities. So this unique identity may be anything. So but generally speaking, because when we are talking of the internet, this is the IP address. Okay, and then they are connected to the internet, so they can communicate with the internet and rest of the world through the communication infrastructure. Okay, so basically, if I put it this way in a single phrase, if I want to put it, then the Internet of Things is nothing but it's a network of physical objects. Remember, it's not the logical objects now, but it's a network of physical objects. And these objects may range from anything to anything, from as small as a shirt button to a large as your truck or a cargo. Okay. Now, basically what we do in the IoT paradigm, the focus is on the three aspects. The basic aspects are three: configuration, the control, and networking. So basically what we require is that each item is required to be configured for communication. So everything needs to be configured. The another aspect is control, which is more like an application, you can call it. So basically what happens is these things may be these may be controlled, and to achieve this control, what we use the networking. Okay, and the networking is performed or it is achieved through the internet of devices. So basically what happens each one of these devices, if I redraw the diagram, so basically what happens is you may have the devices. So you may have a device connected here as I'll put it D1, you have a D2. Okay, so first thing would be required that D1 needs to be configured. And this D1 once configured, it can connect to the internet. And what this can be used for. So what we can do is we can connect this to the internet. Now, in turn, what happens is it can control another device like D2, which is also connected to the internet, or it can get controlled by D2, which is also connected to the internet. So basically what happens, networking provides you the two-way exchange of the information. The objective is to control. Okay, and when we are talking of the devices, these devices may be pump, it may be a utility meter, it may be a car engine, or anything it may be. Okay, so basically what happens, this everything needs to be first configured, then needs to be connected to the internet, and in turn they need to communicate with each other for controlling or getting controlled, both the purposes. So the basic application of any or every IoT is the control. Okay, and configuration is requirement so that we can connect to the internet, and networking is the facilitating part of it, which establishes the communication and which facilitates the communication of the signals and the data. Okay, so basically what happens, so it's a new revolution in the capabilities of the endpoints that are connected to the internet. So basically what happens now, this D1 or D2, which are the endpoints, now they can be used for several other purposes, which we have not used them for so far. Say a car engine. Okay, we can check whether the car engine is running or it's not running, or whether there is sufficient oil in the engine, or the oil has drained out. Everything we can do. What is the reading? The smart meters you might have heard of. So now you don't need to send a person to take the reading, and you can get the consumption records or the consumption related data at one point only. So that's how the IoT is revolutionizing the entire sphere of the endpoints. Okay. So once we have concluded that IoT is a network of physical objects, let us first find out the scope, that what is basically the scope is. So here, rather than defining the scope, what it says is that it is not limited to connecting the things like devices and application to the internet. No. The scope is basically this one here. That is, we want to communicate and exchange data. That's what the basic purpose is. So what it does is the IoT allows all of these things which are connected to the internet using this technology. They allow the communicate and exchange data, and the data may be either a control data or it may be an information. So what happens is, suppose the engine may send its status information that it is running, and then in turn it can get a control signal that no, this needs to be stopped. So that's what the kind of scope of IoT may be. Okay. Now, this is the last point is very, very important, that when we process this data, it will provide us various applications towards a common user or a machine goal. So this is what the people are really building the entire sphere, or the entire paradigm. New paradigms are appearing because of this capability which has been provided by the IoT. So basically in most of the cases, what happens is IoT is used to collect the data. Now, once that data is available, the data will be analyzed remotely, and then based on that, we can take certain decisions. Okay, what to do with that? What is happening or whatever is being provided to by the latest application in this is the contact tracing for your COVID patients. So that is a very, very important application, which is again using the same technology which are used in the IoT devices. Okay, so roughly speaking, IoT looks like something like this, that what you have is, you have an Internet of Things here. So it's basically an internet. It's an internet, and everything is starting from your home, your earphones, or a music system, a cinema, a camera, calculators, everything gets connected. You have a car here, even your machines are connected here. Later on, I'll tell you slightly, I'll modify this. So basically, that's what the IoT looks like. Okay. Now, why this new idea? What is the difference between the classical internet and IoT? That's what we have to understand it. And unless we understand it, we may not be in a position to appreciate the requirement for the new technologies and the new protocols for IoT. So basically what happens, the most important aspect is, the idea in the IoT is move from internet to people, because in the internet it's basically a physical communication, and it is people oriented. So basically what happens, people here may be the active computing machines. Okay, remember, so when the original idea of the internet was that the the devices or the endpoints which are there on the internet, they somehow, the final entity involved there is the people. Whereas in the Internet of Things, the paradigm is basically, it's a drift. And the shift is that the Internet of Things is a plan to connect things also using the same medium. Please remember, we'll still use the same technology, same medium. But remember, the difficulty would be that because the internet was primarily connection between people, whereas IoT is primarily connection between things. So there has to be certain changes, because the end point is now a dumb system. Unlike in the internet, where the end point is your an intelligent entity which can interpret or which can take control of so many aspects. So, and for this reason, IoT is really evolving as a separate field or a separate specialization of engineering, which has everything in it. I'll come to what is meant by everything. So basically, if I see it here, that how the Internet of Things, the communication, evolution of the communication. So basically, if you remember, pre-internet, it was human-to-human communication. So you have fixed and mobile telephony and SMS. So basically, they were being used either through the voice or through the SMS, and they were being interpreted by the humans. At both the ends of the communication system, you had the humans. Now, from a pre-internet human to human, we moved to Internet of Contents, which is WWW, where what we were trying to do was that we had some information and we tried to publish that information, or really disperse that information among the masses. So basically what we came was the email, which did not require the other side to be available or to be hooked when you are making the communication. Then you have the information. So a pure www, where you have the websites, and then you have the entertainment industries, where remember, this entertainment and today's entertainment is slightly different. Here, when we are talking in the Internet of Contents, this is basically the still contents we are talking, and we are not talking of the interactive contents which are provided by today's internet. Okay. Now, if you see, from pre-internet to Internet of Contents, what we did was we introduced, or we included, some smart networks. So the networks were the smartness was in terms of finding the routes, in terms of finding the contents, the search, and so on and so forth. Okay, and then after that came the Internet of Services. Now here the most important service was the e-commerce, where the people now started using the internet for carrying out the commercial activities. So be it the purchase of the goods, or in fact, the banking system will also fall in this particular area. Okay, so the internet, internet banking or your e-banking, whatever you can call it, your mobile banking, everything that falls in the internet of services. So now banking is one service, and what was happening was that the service, this service was being provided through the internet now. So you don't require to visit a bank premise physically, but you can carry out all the transactions sitting from your home, and the funds can be moved from one account to another account without involving physical movement of currency and so on and so forth. Okay. In fact, this has now gone beyond that. You don't require even to move your check which you produce to the bank, and banks are really doing or moving the checks also over the internet now. Now, after this, so here what happened was we introduced some new smart IT platforms like your smart banking systems and the services. So banking services in particular are benefited, financial services you can call it, the whole financial system got benefited from here, and we included the financial services. So services were made a little smarter. Okay, now came the real revolution, which is happening and which has affected the life, and that was the social media. So you came with Skype, Facebook, YouTube, and so on and so forth. In fact, I don't remember even all the social media names. Here, basically, it became an internet of people. Now, what was happening were people were exchanging their views, their ideas, their contents, whatever they have, and from one person to another person. Remember, in web initial, when you are talking of the internet of contents and internet of people, maybe some of the activities are the same. But internet of content was you host it and anybody can access it. Whereas internet of people, it's a people to people. So you may connect one person to the another. So it's a peer-to-peer communication rather than dispersion of the information itself. And Internet of Things is, you can call it the fifth generation of it. And so what happens here is now the communication is machine-to-machine communication. It's no longer people-to-people communication, but it's a machine-to-machine communication. And the fields where it has been used is the identification. You have the remote identification of the machines. You have the remote identification of the people, and so on and so forth. You can track. And in fact, IoT, if you read the history of IoT, the evolution of IoT started with the tracking of the cargoes. That was the first application which was built not by a computer engineer, but by a logistic expert who wanted to keep a track of the cargoes which were moving away and coming into the warehouses. So it was a courier service, and who built the first IoT platform, monitoring, metering, and so on and so forth. And the later applications are now automation, the plant automations, the actuations, the payment systems, and so on and so forth. Now, in the last stage, what has happened is now everything has become data, and ambient is become more important here. So you have the data, which is smart, means it can get the devices. The data can act upon the devices. So you have the control signals in the form of the data. You have the ambient context. That is the best example, if I remember, I can recall, is your targeted advertisements and your location sensitive services or location based services. So from pre-internet to the Internet of Things, a lot of things have changed, and that's how the Internet of Things has evaluated. And now we are in this era of Internet of Things where everything is in the form of an intelligent thing. Okay. Now the next part of it is, which is evolving, and that is connecting the people with the things. Just see this example here. This is particularly relevant to the healthcare industry, where what you want is that this is a person who is being monitored for various health conditions or health related symptoms. So you may have an ECG sensor, you may have a motion sensor, you may have other sensors which are, say, temperature sensors, the pulse rate sensors, and so on and so forth. Okay. and he is also connected to the internet. He is connected to the internet or through mobile device. That is the mobile phone. The mobile phone. Okay, so he is carrying a mobile phone, and the mobile phone is acting as the data collection device, and then everything is sent to the internet. Now just look at this. You have a hospital. This is some other establishment. This is the temperature or the weather monitoring system. Now, the moment his ECG is reporting some disturbance, the hospital gets activated automatically, because before the patient comes to know that there is something wrong with his ECG, the hospital has already detected it. So it can make the preparation, it can make a call to the person, oh, please stand where you are currently. Okay, and wait for our ambulance to reach there. And means I may not be in a position to comment whether it is really useful or not, but yes, that's the kind of applications people are building. So this is the next part, where what is happening is the person will be carrying his mobile phone, and through mobile phone he can connect to the whole of the world, including his air conditioners at the home, or it is oven at the home, or the refrigerator at the home, or to the hospital, or to the children in the school, and so on and so forth. So everything he can keep a tab through the mobile phone which he is carrying. Remember, mobile phone will not be used as the data collection. It will not be data generation device, but it will be only a data collection agent or a data collection platform. It will be used. Okay, now this is another aspect which we need to really understand, that so far what we are assuming is that everything is connected to the internet, and so whatever communication happens, that happens through the internet. Yeah, to a large extent that is correct, but the IoT is not limited to that aspect only. So what it provides you is, suppose you have a home, and in your home you have the lighting system, you have the air conditioners, you have the say an oven or a microwave oven or a refrigerator and your washing machine and so on and so forth. Now, if you do not want that data to be sent out, what you can do is, these things need to communicate with each other. So basically, when we are talking of Internet of Things, this is also an important aspect, that everything can be connected to everything. So it's basically not that, say, this police. Now, police may have its own network, okay, though it might be still using the internet technologies, but internet is not necessary for one police vehicle to connect to the another police vehicle. It can have its own system. Yes, it can have connectivity through internet also, no doubt about it, but yes. So basically what happens is, these devices can communicate with each other. Now, so what happens is, it makes the devices, or the devices may be complex and heterogeneous. So that puts a lot of challenges rather than putting everything through the internet. Remember, now if a car is communicating directly with the petrol station, then yes, the two devices are very heterogeneous in nature. They are heterogeneous type in terms of their size, in terms of their capabilities, and so on and so forth. So, but yes, Internet of Things, when we are talking, then it is not necessary that every communication happens through the internet. Okay, now why people are really talking that much of the Internet of Things? So basically, that is what you need to understand. Nothing can sustain, or nothing can be really, people cannot like, or it cannot last longer unless it provides some financial opportunities, and in terms of making the people's life a little bit more comfortable. Now, IoT has provided large economic opportunities in terms of the automation and the communication, and large opportunities are had added to the comfort level of the people also. So what happens, just let me see a few of the fields where there are limitless opportunities, I'll call it, say consumer. So you have smart home controls, say lighting control, your security comfort, and so on. You might have seen those cars, actually, very high-end cars, where the seat can adjust itself to the as per the body of the rider. Okay, so whether a driver, if it is a slightly less height or it is of more height, then it can adjust the height automatically. Okay, that's provided by the Internet of Things. Okay, so this is IoT. You have optimized energy usage, the maintenance, and so on. And so consumers can be benefited largely using these in these areas. You have the retail, where the most important aspect is product tracking, where your product is going. You have the inventory control, so even your shelf can say automatically that yes, now I'm left with only 5 of these quantity, whereas the annual consumption or the average consumption in 1 week is 10 pieces. So please fill up the shelf immediately, because now the number of items available on the shelf is less than the average consumption required for week. So if your policy suggests that, okay, there must be an inventory for 1 week, then yes, please fill up the inventories. You have focused marketing. So that's how the retail. Medical is one field which is getting the real benefits of the IoT. And so you have the wearable devices. And in fact, I have been given this information that this entire workshop or the program is with regard to this aspect of the medical. So here you have the wearable devices which can monitor the human health and the parameters of the humans, and then it can really take some decisions, communicate those parameters, and then so healthcare industry is one of the biggest beneficiaries of the IoT technologies. You have implanted devices. Your pacemakers are the biggest example of this. So you can know the health of the pacemaker. Earlier, the pacemakers used to be quite dumb, and it was basically the judgment of the physician as well as the person that when to get it replaced. Now your pacemaker can give you the indication that no, I have run out of the battery, and so please you prepare for a reimplant. Okay, you have telehealth services and so on and so forth. So this is one field where you can be benefited immensely through the IoT, and you can keep talking about it. And I think in subsequent days you will be talking more in more depth on these aspects. Military applications, yes, again these are very, very important applications. One of the applications which we have heard quite recently is the smart fence which is being built on Indo-Pakistan border. So that is another example. This is a good example and application of the IoT. So you have the resource allocation again here, that which in fact the rifles can be fitted with these IoT devices, and so the rifles become now intelligent devices. They can communicate. In fact, but please remember, rifles cannot be controlled remotely. Okay, but yes, you can keep track where the rifles are moving, who is using them, and so on and so forth. That we can do. Threat analysis, we can smart fence. I have given you the example. Then you have the troop monitoring, and so on and so forth. In fact, with military, there are a large number of applications. But yes, in military, there are a lot many other challenges also. In fact, even if we are using the IoT, so IoT poses more challenge than solves the problem, and that's why in military the uses are very slow, and they do not get built up that easily. You have industrial applications. The most important among them is the smart meters, which are the energy monitoring devices, you can call it. Then wear out sensings. So that is for wear and tear and corrosion control. Then you have the manufacturing control, climate control, automotive. Yes, in fact, the cars today, they have large number of IoT devices fit in, and the latest of them, which will be there in the next generation of cars, is the tire pressure sensing. That's what is going to happen. You have the traffic flow, anti-theft locations, and so on and so forth. So the opportunities are immense, and the another field where a lot of opportunities exist is the agriculture. So from crop management, the soil analysis, the irrigation analysis, the managing the drip irrigations, and so on and so forth, managing the health. In fact, one of the first applications which fascinated the people a lot was that a farmer in Gujarat, I think, he developed a system wherein he was switching on and off the pump using a mobile phone. Okay, that was the biggest one of the very, very important applications. Now, the important aspect is that you may say that, okay, it's a very small device or it's a very small application. No, it's not very small application. Because earlier the difficulty was that for agriculture purpose, electricity is available only during night. Okay, and in places or in the state like Rajasthan, if you go to a place like Churu, nights are very cold, very, very cold. In fact, they are more often than not, they are freezing. So a person traveling or person staying in that wild cold in a field, that was torturous. So the agriculture systems or the irrigation systems are being designed where the person can move the pipes, switch on and switch off the pump, sitting from his home. So that is the kind of applications the agriculture platform or the agriculture people or the farmers are looking for. But yes, affordability is one concept, concern which we need to understand and which we have to really take care of. Okay. Now let me just discuss few of the applications which people have built over the period of time and which are quite successful and which have really created some interest among the people with regard to IoT. Okay, the intelligent home. I think this is the biggest application which facilitates the people. Now just see it here. In a typical home, what we are looking, we have a geyser, you have the toilets, the lights, the speakers, the window shades, and so on and so forth. Now everything gets integrated or they are connecting to each other. You have the lights being put on or they are being switched on as and when there is a person in the room and the ambient light is not sufficient, so lights will be switched on. The moment he goes out, the light will be switched off, and in large number of hotels, you might have seen the motion sensors sensing lights. So whenever there is some motion in the corridors, the lights keep coming. Otherwise, the lights are off. So that's how you can conserve energy. A lot of energy can be conserved. And energy conservation is not only important with regard to the money, but yes, carbon footprints are also equally important these days. So you can lower the window shades, you have the laptop, your TV can be connected, and so on and so forth. So this is a very, very important application. In fact, the things have gone beyond this now. So you can, one of the case, which is a very very important case with one of my colleagues, when he was away from his home, he has put a camera in his home, and what he found was through that camera that a burglar is trying to enter into his home. He was some 1,000 kilometers away from his own home, and on the monitor he was seeing that burglar trying to break open the door, and so he made a phone call to the attendant in the home. अरे कहाँ घूम रहा है वो, घर का दरवाजा तोड़ रहा है. So the person who was kept there for guarding the home, he was not able to find that a person is really trying to break open his door, but you were able to really see it live on the camera and alert the chowkidar. Rather than chowkidar alerting you, the owner is alerting the chowkidar. So that's the kind of applications people have built on IoT platforms for intelligent home or smart home, you can call it. This is a smart egg tray. So basically what it does is egg minder syncs with your smartphone to tell you how many eggs you have got at home. So this is a real application which has been built. So it can tell you how many eggs are there, so you can take a decision that whether to bring the eggs or not to bring the eggs. Smart washing machines. This is also a very encouraging application. So the first Indesit company washing machine designed to be integrated in a smart ecosystem, covering a wide range of use cases. So information, the operation, you can, okay, you feel that, okay, machine takes some 50 minutes or 30 minutes to complete. So when you start walking from your home, from your office, you can switch on your washing machine. And by the time you reach home, your clothes are already washed, and only thing you require is you can spread them for drying up. Okay, and so this is how the washing machine is a smart washing machine can be. Smart lighting, so that this is a very common application these days, that you can control your bulbs one at a time or all together, find just the right shade of white, pink, that perfect tone of anything you can do. So depending upon your mood also, you can change the colors of the light and so on and so forth. So that's the smart lighting. Smart AC, this is quite talked about application, where you can decide the schedules, when to switch on, when to switch off, and so on and so forth. So basically the purpose here is to maximize the energy savings. Yes, this is another important application. This is now related to the human health actually. So what it is doing is it's a small smart sleep system. So you visualize your sleep cycles, understand what wakes you up and compares nights. From the palm of your hand, you can now control your personalized wake up and fall asleep programs. One of the application which was offered to me was when I was buying my new car. I was told there is what they call it, the Smart Connect of the Suzuki. So that will really monitor your driving behavior, and then based on your driving behavior, it will give you that where your driving is faulty, how can you save upon more fuel, where you have missed or you have avoided an accident, and so on and so forth. So that is driving behavior analysis software is a reality these days. Weather station, I think this is quite common, which we are all knowing about. Slow cooker, so this is an electric cooker, and you can enjoy biryani. You can just switch on it from your office, and by the time you reach your home, you don't require to wait for five hours to cook your biryani. You can just keep the things ready here, and you can cook your biryani here. Garbage cans means this is a very, very significant development for a country like India. But in fact, in India, it may not work because people do not put their garbage into cans. Actually, we are in habit of just throwing the garbage and put the responsibility of picking it up to the municipal authorities. And in fact, municipal authorities never does that, and it's the stray animals which do it. So smart garbage cans basically alerts when it needs to be emptied, so smarter collection decisions can be made, and so on and so forth. Gardening is another application, so it can find out what is the soil health, what is the moisture levels, and so on and so forth. Okay, so once we have discussed about these applications, now let me come to the formal definitions and the formal more formal applications and the requirements of IoT. So basically what happens in IoT is it's a fully networked and connected devices sending analytics data back to cloud or data center. So now I've started discussing about the architecture. So basically what will happen is every device, whether it is, if you see it here, this is a data collection device. Okay. Now this is some of these devices are fitted here also. So they are this is collecting the device, and finally this entire data is being sent either to the cloud or over the internet for analytics. So that's how it happens. So Internet of Things is fully networked and connected devices sending analytics data back to cloud or data center. And then the definition of Internet of Things is that the network in which every object or thing is provided unique identifier and data is transferred through a network without any verbal communication. That's what the definition, or how do we define the Internet of Things. So you don't require some commands actually. You don't require some voice commands or any other kind of commands, but it keeps on sending the data automatically depending upon how you have configured it earlier. So that's what the IoT is. And so the scope of IoT is not just limited to connecting the things to the internet, but it allows these things to communicate and exchange data. So each thing can communicate data with each other. So when suppose you have an air conditioned kitchen, and if suppose your oven is open, and then maybe that the air conditioner is switched off so that it does not consume more energy. That's so what will happen is the oven will communicate with the air conditioner that the moment you open the oven, to remove your cooked food, then yes, the AC needs to be switched off so that you can save upon the energy. And process them as well as control them while executing the application. So IoT is basically, this is how it defines the complete sphere of IoT. So if I take the formal definition of IoT, so formally, IoT is a dynamic global network. I'll come to the term dynamic a little later, actually. Infrastructure with self-configuring capabilities. So these are some of the terms which are there in the bold. These need to be really understood. So we have the dynamic global network, self-configuring capabilities based on standard and interoperable communication protocols. So these communication protocol needs to be interoperable. I'll come to that and I'll discuss each one of them in some more details. Where physical and virtual things have identities, so you have the identifications, you have physical attributes, and use intelligent interface and seamlessly integrated into information network. So these are the different components of, or the different characteristics of the IoT, and that communicate data with users and environment. So there are many things which we need to take care whenever we are dealing with the IoT. So let me just come to each one of them. So what is the meaning of these dynamic global networks and self-adapting is that adapt the changes with respect to changing context. So one of the things which I told you, suppose your oven is open and then air conditioner needs to be switched off. So that is how the dynamic global network, it's a dynamic network. And suppose your oven has gone off, then yes, air conditioner needs to be switched on. That's what the idea is. Then you have the self-configuring, because the number of devices is really large. So fetching latest software updates without manual intervention. So they must have these capabilities, and you might be observing it on day-to-day basis in your mobile applications, that it informs you of the updates. Interoperable communication protocols is communicate through various protocols. So there is no standardization of the protocols. So these protocols needs to be interoperable, and from one manufacturer to the another manufacturer, the devices must be able to communicate with each other. Then unique identity, so such as unique IP address or a URL. Then integrated into information networks, everything now needs to be integrated into a single network, which allows to communicate and exchange data with other devices to perform certain analysis. So though the devices may be quite heterogeneous in nature, your communication protocols may also be heterogeneous in nature, but at the end of the day, then it should be possible to integrate them into a single information network, because the devices might be coming from different manufacturers and the different standards are being followed by the different manufacturers. It should not restrict the capacity of these devices to communicate with each other. That's what the purpose of the IoT is, and that's how we can define the IoT. Okay, and the physical design, that requires two aspects to be dealt with. One is the things, that is the physical devices, and then the IoT protocols, which will enable the communication. Let us take each one of them. So things basically refers to IoT devices which have unique identities that can perform sensing, actuating, and monitoring capabilities. So basically what the things will do, it is basically the data sensing platforms, or data sensing, or the data collection endpoints, as well as the data consumption endpoints also. Because say if we are trying to monitor a device, so the device will provide you the data for monitoring as well as it will be monitored. So it must provide you both the facilities and both the capabilities it must provide. And then the another requirement is that it should be possible to exchange data with other connected devices or collect data from other devices. I gave you the example of the oven and the air conditioner. So air conditioner is collecting data from the oven, and once the oven is on, yes, air conditioner will be switched off. That's what is meant by we collect data from other devices and process the data either locally or send the data to centralized servers or cloud-based application backends for processing of the data. So basically what happens is this makes, or it really puts one more requirement, that at the end of the day, there needs to be a central place where the entire collected data can be analyzed. And whether it may be the servers or it may be clouds, that doesn't make a difference, because the only difference is that how the infrastructure is provided. As far as the IoT platform is concerned, it doesn't make any difference. Okay, now coming to the architecture. So once we have found out that yes, there are many things to be done, so we need to have a formal architecture of the IoT. So in most of the cases, though standardization work is still going on, and I have serious doubts that it is going to come out very soon. But roughly speaking, there are 4 layers which people have agreed upon in IoT architecture. Though different people are giving different names to each of these layers, but roughly speaking, or broadly speaking, not roughly, but broadly speaking, the purpose and the definitions and the tasks allocated to these 4 layers is almost identical. So the lowermost layer, which we are calling here as the sensing and identification layer, some standards or some people will call it a hardware layer or hardware interface layer, and so on and so forth. So basically, this layer is responsible for the fundamental sensing. So data collection starts from this layer. Okay. So, and then the next layer is the network connection layer. So whatever data is collected by this layer, either it is a GPS sensor or a smart device, an RFID or and so. Now this needs to be through this layer. It needs to be processed or it needs to be transmitted to a remote location where this data can be processed. Okay. And then you have the information processing layer. So this is the data centers, the search engines, your cloud, and everything is placed here. Okay, so everything is placed here. Here, the sensing layer has provided to you. Now this layer, this data will be processed. And once this data has been processed, it will be fed for consumption. Now, it may be anything. So suppose you have the electricity meter or a smart meter. Now, based upon the load on the grid, now you can monitor the smart grid. That okay. And in today's context, it's very, very important. Only today we have seen a big power outage in Maharashtra. So many things have really gone out of order there. So this is the smart grid application. You may have the green building application. So if your sun is out and you have sufficient ambient light in your home, then there is no need to switch on an artificial light. You have the smart transport. So smart transport basically refers to diverting the transport, the vehicle or the traffic, setting the timings of the on-off timings of the traffic lights, and so on and so forth. You have the environmental monitoring, and so basically the application, integrated application layer, it consumes the data, and based upon that, it takes the decisions what to do. Okay. Now there are many technologies which are involved. We have seen there are 4 layers, so and each one of them has different technology. So let me just give you a brief introduction to each one of these technologies. The first and foremost technology is the hardware technology, which is the lowest layer. The second is the network or the communication technologies. And related to this is your protocols for communication. Then you have the software, that is the how to write the applications. So it's application development platforms, and then the cloud platforms where this entire data will be processed. So the sometimes you may wonder that why do we require a separate kind of cloud platform for IoT devices. It will be a little clear. It will be clear in a little while from now. What happens is the sheer data which is made available by these IoT devices, that is tremendous amount of data. And so unless the cloud really facilitates this collection of the data and analysis of this data in a specific way, the data may not be of any uses. So the cloud platforms should facilitate application development, and lot many people or lot many companies, including IBM or HP or lot many companies, they have their own IoT clouds where they facilitate application development for some of the IoT devices, using some of the IoT devices. Okay, now coming to the hardware technology first. So in the hardware, this is a typical block diagram of an IoT device. So basically what it has, it may have a CPU, it will, or if you require some more capabilities, it may have even a GPU. And this small CPU and GPU is required to have onboard processing of the data. So suppose you have a camera. Now camera data is really a large amount of data, so you may require the compression, and for implementing the compression you may require some CPU. So, and for connectivity you may require some USB or RJ45 Ethernet. Then you have the memory interfaces. The different type of memories may be there. You will require some storage interfaces and so on and so forth. You have the external communication through HDMI, the audio communication, and then you have some universal communication. So IO interfaces for sensors, actuators. So that's how the entire hardware of or what is you can, it's not the entire hardware rather, but these are the different components of the hardware on which you need to think while having any IoT application being built. These are some of the standards which are available. In fact, these are some of the basic IoT platforms. So you have the BeagleBone Black, you have the Intel Galileo, you have the Raspberry Pi, you have the Arduino, and so on and so forth. Arduino and Raspberry are more common, people are used to, but Intel Galileo is also quite popular, and you may have a lot many hardware. Now what this hardware provides you is basically it provides you the generic components, and then based upon those or using those generic components, you can see it here. This is an RJ45. It may be this is a one kind of different kind of interface, and so on and so forth. So it will have some basic components available, and then these basic components, there is some noise coming, so please just avoid these kind of noises. Okay, and that's how we do use them actually. Suppose you want to use the project, then this is your, say this is Arduino board, and it does not have a display. So what you can do is you can connect a display to this. So, and then you may have some sensors, because some sensors are inbuilt on this, or you may have an external sensor connected to it, and suppose you want to display the temperature, yes, you can display the temperature here. So that's the kind of projects you can create on these IoT platforms. Then on the same hardware, you have the sensors and actuators, which are different. Means a large number of sensors and actuators are available. So you have the machine vision and optical ambient lights. You may have the position sensors, proximity sensors. You may have the motion, velocity, displacement. All different kind of sensors are available. You can use these sensors for purpose, and you can build the applications using some standard hardware, or you can design your own hardware also. Then you have a set of protocols, which are basically the communication protocol, I'll call it, or the typical networking protocols you can call. And when I'm talking of the network, it's the internet protocols. Now here there are certain, the link layer protocols are more or less the same, but yes, there will be some differences because of the sheer size of the data and the pace of the data. I may not be really in a position to discuss those variations, but in few cases, even the standard 802.3, 802.11, 16, they are used, but you have some specific protocols like 802.15 which are used with the IoT devices. You have 2G, 3G, 4G, and in fact, in quite a few cases, in even multiple communication protocols may be provided. So that is the requirement of the communication protocols, of the link layer protocols. You have the networking layer protocols, you have the transport protocols, but the basic difference comes here. Here, if you see HTTP, yes, it's quite standard. But in IoT, the application HTTP is a lightweight HTTP in comparison to your full-fledged HTTP. Then you have the constrained application protocol, which is COAP. You have the WebSocket. You have MQTT. These are very, very specific to the IoT platforms. I'll be discussing a little bit of each one of them today itself. Okay, these are the protocols. So basically, we are all familiar with these protocols. So 802.11a, you have the 802.11ad. So different protocols, they can be used. And for wireless LAN networks, the speeds vary from 1 Mbps to 6.75 Gbps, depending upon the standards. Then you have the 802.16 set of protocols, which is WiMAX protocol. You have LRW PAN, which is wireless public area networks. So like Zigbee is one of these protocols. So for very small data rates and very small distances, this provides you a low speed and low cost communication for power constrained devices. Okay, this we have already given. Okay, and so now let us see the integrations, how these different technologies are placed with respect to each other. So if you see, these are the typical technologies which we have been using so far. These are all your cellular technologies. So you have 3G, you have 4G or LTE, you have GPS, you have 2G or GSM and GPRS, and so on and so forth. Now 4G and 5G will also add up to this. So the communication technologies, the requirement with the IoT is that it should support a wide range of communication technologies, because we do not know the deployment environment, because not necessarily the place where this needs to be deployed, you may restrict it using one particular communication technologies. Similar is the case with your Wi-Fi and WiMAX technologies. So you have the Wi-Fi, and then you have the 15.4, you have RFID, you have NFC, and so on and so forth. And then you have the other technologies like Ethernet, your PLC, and so on and so forth. But there are certain, so basically what we want is that, yes, a common set of technologies has been agreed upon, and so these are the different technologies which we are using, and the requirement is that each one of them, it should be interoperable, the devices should be interoperable around these communication technologies. Okay, so the application layer protocols, this is where a lot of difference has happened in the IoT paradigm actually. Because of the two basic constants. One is the power constraint, that the available power with the endpoint is limited. And the another one is the size of the computing. The overall computing capabilities of the endpoints are quite restricted because of the power consumption issues, as well as the physical size of the devices. So, and cost is also one concern. So what we have is, we have small computing power, which will require small power, and which can be manufactured with small costs. So the protocols are quite different here. So you have the constant application protocol, you have the message queue telemetry transport protocol, you have extensible messaging and presence protocol. XMPP is one of the most widely used protocols with the in the IoT. Then you have the low power wireless personal area networks. So these are some of the protocols. I'll be discussing a few of them in some detail. Okay, so this is how they are relatively placed if I see the protocols here. So the relative position is like this, that in the application layer, you have all these protocols including web sockets, DDS, AMQP, and so on and so forth. Okay, this I have already discussed, so I will not be discussing it further. Okay, so don't need to discuss this. Okay. This is all right. I think these are some of the things which you all know, and I really do not want to discuss them. But what okay. Now, this is one protocol which is really an important protocol in the application layer of the IoT protocols. That is the constrained application protocol. It's basically a machine-to-machine application meant for constrained devices and networks. So the characteristic of this is that this is a web protocol for IoT, and this provides you, it requires very little processing. So the computing power required here is quite limited. It's a client-server architecture, and it's a request-response model. So the initiator will be making a request, and then it will be getting the response. I will be discussing it later. And supports modules, methods such as get, post, put, and delete. These are some of the basic methods which are used in COAP. WebSocket is another one, which is remember here it's a in COAP it's a request response, so it's half duplex, whereas WebSocket is a full duplex protocol over a single socket, and it's based on TCP. And client can be a browser, IoT device, or mobile application. Anything is possible to be a client here. MQTT is message queue, it's a lightweight messaging protocol based on publish subscribe model. So there are two basic models which we are familiar. One is the request response, and another is publish subscribe model. I'll be discussing these models. And it's well suited for constrained environments where devices have limited processing, low memory, and network. So remember, these are all designed for wireless sensor networks and the IoT platforms. You have the extensible messaging and presence protocol. So it's basically for real-time communication and streaming of XML data, and used for applications like multi-party chat and voice video calls. You have the data distribution service. It's a data-centric middleware standard for device-to-device or machine-to-machine communication. These are some of the very, very important protocols. And the important application or the important characteristic of DDS is that it provides quality of service control and configurable reliability. Okay. It's advanced messaging queuing protocol for business messaging. So it's and it supports point-to-point and publisher-subscriber model. Routing and queuing is implemented through AMQP. Okay, this is how logically each of these entities are placed in an IoT application. So what you have is you have the devices which will be generating the data or collecting the data. Then you have the communication and the services built over this. Then these are the horizontal layers. The vertical layer, one vertical layer will be of the management, and another vertical layer would be of the security. Remember, security is very, very important aspect in IoT devices, and then each one of them, the whole application needs to cover each aspect, including the management and security as well as the services. So logical design, it's an abstract representation of entities and process without going into the low-level specifics that we all know that what is meant. So these are the typical functional blocks. So starting from the devices, that's the sensing and the actuation and the communication management and everything. So this is how all these entities need to be placed with respect to each other. Okay, so this we have discussed, so I'll not be discussing it. Okay, now just try to understand the request response model. So basically here what happens is the client sends a request for a data item from the server. Remember, the server what in turn will, so suppose this client may be anything. So suppose your mobile device, let me just assume this is a client. Okay, and you want to know that what is the status of your car engine at this moment. So client will be sending a request to the server, to which your resource is also connected. And here the resource is again the same, that is your car. So it receives request from client, processes request, looks up, fetches resources, prepares response, and sends response to the client. So in turn, what it will send you is, it will send the status of the car engine back to your mobile device. So remember here, the initiation has been from the client. That client has requested a specific resource. And so when the server receives the request, it decides how to respond, fetches the data, receives resource representations, prepares the response, and then sends the response to the client. So, and it's a stateless communication model. That is, once the request has been served, the server will send what it has. Server will forget what it has sent to the client. This is another model which we call the publish subscriber communication model. Now here what happens is, you have now a slightly different design here. See, that you have a broker, you have a publisher of information. So suppose your if I take the same example, that is your car and your mobile phone, you want to keep getting the status of your car. Now in the earlier model, what was happening was, you will be making a request through your mobile device for getting the status of your car. Now in turn, the cloud or the server will check or will get the data, and then it will send the information. In a publisher model, the message, the car engine will become an active component. So it will keep publishing its data, and the broker will keep collecting that data. And if you have subscribed to this data, then you will keep getting this data. So that's why it is called publish subscribe data communication model. So what happens is, publish subscribe is a communication model that involves publisher, brokers, and consumers. Publishers are the source of data, say your car engine, and publishers send the data to the topics which are managed by the broker, and the publishers are not aware of the consumer. You don't require, the publisher doesn't require to know who is consuming the data. It is the responsibility of the broker to ensure that the data is consumed by an authorized entity. Okay. And consumer subscribes to the topic which are managed by the broker, and then when the broker receives data for a topic from the publisher, it sends the data to all the subscribed consumers. That's how it happens. The publish subscribe model works. Then you have the push-pull communication models. This is a slightly more direct method. Here now you have the publisher and the consumer. So you have the message queues. The publisher will put the data into the message queue. So that is what the pushing the data. And consumer, it will pull the data from the queue. That is the pull operation. So for each type of message, you may have a separate queue. Okay, and consumer will keep getting, the publisher will keep pushing the data, and consumer will keep getting the data. So push-pull is a communication model in which the data producer pushes the data to the queue, and the consumers pull the data from the queues. Okay, and what the characteristic or the important point here is that the queues help in decoupling the message between the producer and the consumers. You don't require the data to be consumed immediately by the publisher, but queue will hold that data, and the consumer can get it at the convenient time. And queues also act as buffer, which helps in situation when there is a mismatch between the rate at which the producers push the data. So the queues are used for flow control also. Then you have the exclusive pair communication models. So in exclusive pair communication models, request for setup connection, it's basically a connection oriented protocol. So basically what we do is, exclusive pair is a bidirectional fully duplex communication model that uses a persistent connection between the client and the server, and once the connection is set up, remains open until the client sends a request to close the connection, and client and server can send messages to each other after connection setup. So it's an exclusive pair or an end-to-end communication. Another one is this is how the applications are built actually. So you have the REST-based application communication APIs. So representational state transfer, that is the REST, is a set of architectural principles by which you can design web services and web APIs that focus on a system's resources and how resource states are addressed. And so it follows the request response model. So it's the set of APIs which you can use for building the applications. So this is how it works. So, and it provides you these 6 characteristics. It's a client server model. It is stateless. It can be cached. So that is an important point here, that you can cache the data here. Layered system, it's a uniform interface and it's code on demand. Then you have the web socket-based communication APIs. So it's a bidirectional full duplex communication between client and server, and it's an exclusive pair communication model. So these are set of the APIs which you can use for application development. Okay, this is how these two are differ. REST is a stateless, whereas WebSocket is a stateful. And in scalability, REST is both horizontal and vertical are easier, whereas in WebSocket, it's only the vertical scalability is possible. Okay. Now, once we have discussed about the communication, the hardware and the communication technologies, now the important aspect is the processing technologies, that how to process this data. So there are different technologies which are being used. One of them is wireless sensor network, the cloud computing, the big data analytics, and embedded systems. Each one of them are different from each other, which I hope all of you are familiar with. So just to really introduce you to each one of them, WSN, I think I have had a lot of discussion in the past also, and you are all familiar. So WSN are basically, they provide everything here, starting from the generation of data or the collection of the data to the transmission of data. So in WSN, you have the set of protocols where you can collect the data. So route establishment and everything is possible through WSN technologies within an IoT network. So you have weather monitoring stations, indoor air quality monitoring systems. They're all built on WSN in IoT technologies. And so they are quite, these are very, very simple applications and very, very simple technologies. And most of them have matured now. Okay, this is what is the most important technologies which people are really discussing about. That is the cloud, which offers you now sensing as a service model. Now, remember what will happen here is you have the sensors and sensor owners which are connected to the cloud. The entire data processing will happen on the cloud. And then you have the service providers like hospitals, you may have the warehouses, you may have the typical transport service providers, and so on and so forth. And then the sensor data consumers. So suppose you have the hospitals, then doctors might be consuming, or the health workers might be consuming that data. So this is an important technology here, both of them. That is, in these, a lot of work is happening. So processing the data which has been collected, as well as building the application based on the collected data. So a lot of work is happening here, and there are a lot of opportunities available here. So only thing is you need to think out of the box and build an application based on the collected data. So this is deliver applications and services over the internet. I think the SaaS method for delivering software applications over the internet on demand and typically on a subscription basis. So these are different models, and in this now we are adding a new model, that is the sensing as a service. Okay, now to build these applications, because the data is a huge amount of data, so to analyze this data, you require some specialized techniques which are provided by the big data analytics. So you may have the collection of data whose volume, velocity, and variety is too large. We are all familiar with these characteristics of the big data. And so what you require to work upon is data cleansing, processing, and visualization. Visualization has also become a very, very important point and very important technology, because the sheer size of the data and the dimensions and the variables is too large. So a lot of visualization efforts are required. And the data may be collected from so many sources. So web data, e-commerce data, purchases at departmental stores, the grocery stores, bank credit card transactions, social networks, and so on and so forth. These are the different characteristics of the big data. It may be a structured data, it may be an unstructured data, it may be semi-structured, and so on and so forth. So this is the big data. Okay. Now, there are multiple components in the IoT system. And so whenever we are deploying an IoT system, we need to understand that which template needs to be deployed, or which particular resource or component needs for different kind of deployment. So you have a device which is an IoT device which allows identification, remote sensing, actuating, and remote monitoring capabilities. That is basically your data source, you can call it. The resources are software components in the IoT device. And then you have the controller services. These are 3 services. Then you have the databases, the web service, the analysis component, and the application. So these are the 7 different components of an IoT. Okay, and based on these 7 components, there are deployment levels. There are 5 or 6 deployment levels which people have identified. And the most primitive or the most fundamental is IoT level 1. In IoT level 1, IoT system has a single node, one device that performs sensing or actuation, stores data, performs analysis, and hosts the application. Everything is within the device itself or within the thing itself. And they are suitable for modeling low cost and low complexity solutions where the data involved is not big and the analysis requirements are not computationally intensive. So very, very simple data. So you may have, say, you may like to monitor the temperature of your home. So you will put the data, the sensor, this temperature sensor, as well as the display within the same device. That's how it happens. So you have the application. So you have the monitoring node. So this is your monitoring node. You have the monitoring device, the resources, and so on and so forth. And finally, all of them are connected to the database. Cloud may be one of the components or may not be, but more often than not, in level 1, there is no cloud involved. Okay, say home automation system may be a level 1 system. Okay, so you have the air conditioner, you have the sprinkler, you have the electric pot, the intrusion detection, doorbell, and so on and so forth. Okay, now in level 2, you have a single node. Still, it's a single node, but it is now connected to a cloud storage. And in connecting it to the cloud storage, so we require some more a different kind of communication. So what may happen is you may have the device resource, the controller services would be required, which are here built in the device itself. Okay, and then either it may be a REST or a WebSocket based communication, and you may have the database. And now this portion is on the cloud, and because it is on the cloud, it can be accessed from the remote location also. So suitable, these such systems are suitable for solutions where the data involved is big. However, the primary analysis requirement is not computationally intensive. So smart irrigation is one such example. In level 3, it is still a single node. It is still a single node. Okay. There are solutions where the data involved is big and the analysis requirements are computationally intensive. So what is happening is a lot of data analysis or the computation will be held here on the cloud itself. That's how the difference is. So see, the cloud storage and analysis happens on the cloud here. So a tracking package handling, that is an example, so which is a level 3 example. Now, up to level 3, it's only the sensing device. There is only one sensor. In level 4 onwards, there are multiple devices. So multiple nodes that perform local analysis. Data is stored in the cloud, and the application is now cloud-based application. So you may have more than one monitoring node may not be monitoring the same quantity. They may monitor the same quantity or the same physical phenomena or physical quantity, or it may be slightly different also. So local and cloud-based observer nodes, this is another one. The observer node concept is introduced here. Here there is no observer nodes up to level 3. Here you have an observer node, so which keeps what data is going to the cloud and how the data is going to the cloud. So noise monitoring is one such case actually. Okay. Level 5, again the same, but now the coordinator node collects data. You have a separate coordinator node also. So the level 5 has multiple end nodes and one coordinator node. The end nodes perform sensing, and the coordinator node collects data from the end nodes and sends it to the cloud. Okay. And now the endpoints may themselves may not be these. Remember here the difference is this one, that this is now a full-fledged network in itself. Okay. So you may have a separate coordinator node which is sending the data to the cloud. Then you have the level 6, which is as on date is the highest level of deployment. That is multiple independent end nodes that perform sensing or actuation, and data is stored in the cloud. The analytics component analyzes the data and stores the result in the cloud database. The results are visualized with the cloud-based application. So now visualization is also added here. And then the centralized controller is aware of the status of all the end nodes and sends control commands to the nodes. That's how the level 6 controls the devices also. Okay, there are still some challenges which needs to be addressed with the IoT. Connectivity is one aspect, the power management, the security, the rapid evolution, and so on and so forth. These are some of the challenges. I don't think there is connectivity is important because more often than not the IoTs will be deployed in challenging environments where the connectivity is a concern. Maybe the terrain is not conducive for the technology, the communication, the persistent connection may not be available. Power management, because most of them they are battery powered, so power management is an issue. Security, yes, that's a very, very important concern. That physical security is one aspect, but the data security is more difficult to address aspect. And then the rapid evolution, because the hardware will be changing very, very fast. So your application needs to need to keep pace with the changes in the hardware technologies, software technologies, the application requirements, and so on and so forth. So I thank you very much for listening me patiently. I hope it has been you have been benefited through this talk. Thank you very much. And now I open this discussion for open this talk for discussion. Thank you.
So any participant, if you want to say something or ask something, you have some queries or doubts.
Any participant want to ask any question regarding the IoT, introduction to IoT from sir? I think, sir, everything is clear to all the participants. And
yeah, I think it was a quite introductory.
Yes, sir.
We do not have many queries here, but yes, you need to now start thinking in terms of this and develop certain applications. Then this will be really of useful. Thank you very much.
Thank you, sir, for joining us and sharing your valuable time as well as information for all of us. I would like to thank from the entire GWC family for this nice presentation. Thank you very much.
Thank you very much.
So all the participants are required to join the first session of tomorrow at 10 a.m. sharply at 10 a.m. Shyam sir, you would like to share any information regarding tomorrow's session? You can share with the participants.
Tomorrow there will be 3 sessions like today, and the timing will also remain same. The first session will start at 10 o'clock, then the second session at 11:45, and the third session and the last session will be at 2:15. So tomorrow's session will be same timing as of that today, and I have also shared the complete schedule on WhatsApp also. So those who are in WhatsApp group can see it from there also. And there are some requests from the participants that PPTs are required to be shared. So I'll share all the PPTs with you all people on email or WhatsApp, wherever. Thank you very much, all of you, for participating.
And
Please
one thing I
take a
want
note
to one thing I want to ask for all the participants that please stick adhere to the schedule and attend all the sessions actively. Your attendance will be monitored through Google Meet, and this attendance will be shared with AICT. Then only the certificate will be generated.
So if due to attendance you don't get certificate, that will be like an unfortunate event for us also. So I request all of you to please log in timely and attend the sessions. Your 80% attendance is desired to get the certificate. Thank you very much for joining today, and we'll meet tomorrow in the first session at 10 o'clock.
Thank you, sir. Thank you.
I will share the link of tomorrow's sessions in the evening, late evening. I will share the new link for tomorrow's sessions. Thank you very much.